Okay, the question is for a chemical reaction between two species with activation energy EA and heat of reaction, that is delta H, the correct statement is. So you know that when we write this potential energy diagram for the reaction, this is uh, either like this or like this. This one is for exothermic reaction, and this one is for endothermic reaction. Okay, now whenever there is any reaction, there should be some activation energy. Only then reaction can take place. If there is no activation energy, you know it is written minimum possible value of activation energy is always zero. That's not true. It may have some value, but for all the reaction it is zero. It is not true. Second is, you know this one is activation energy for the forward reaction, and this is activation energy for the forward reaction, and this one is delta H. So for endothermic reaction, activation energy for the forward reaction, that is equal to delta H plus activation energy for the backward reaction. So minimum energy should be equal to delta H. Let us say activation energy for the backward reaction is 0 minimum. So activation energy for the forward reaction is equal to at least delta H. So this is the correct statement, but there is a multiple correct options. So B option is correct. Now come to the next. Since activation energy is a kinetic parameter, while delta H is a thermodynamic parameter, minimum possible value of EA has no relation with delta H. That's not true. Already we have done this, that activation energy for the forward reaction equal to delta H plus activation energy for the backward reaction. For exothermic reaction, it is other way out. So activation energy for the backward reaction is equal to activation energy for the forward reaction plus delta H, or we can say activation energy for the forward reaction is equal to activation energy for the backward reaction minus delta H. Okay, now activation energy is always 0 for atom-atom reactions. Yes, when we have, let us say, hydrogen atom combined with hydrogen free radical, combined with hydrogen free radical, we get hydrogen gas. There is no need of any activation energy. It will immediately combine and we get hydrogen molecule. So activation energy for an atom-atom reaction, because activation energy required for the breaking of bonds. Okay, so in this case, see, there is no energy required when there is only atom. There are no bonds at all between the atoms. Atom combined with atom, so we get a molecule. So B and D, that is the correct options. Next question. For a chemical reaction, time taken for the initial rate of reaction to fall to 90% of its value is found to be independent of the initial concentration. So in which reaction rate of reaction is independent of the initial concentration? It is only possible when there is a ratio of these two. So for first order kinetics, time is 2.303 upon k log of a naught by 80. So initial rate of reaction to fall to 90% of its value.